Next divisions Lenz law. A German physicist, Heinrich Lenz, performed his own experiment on electromagnetic inductions and deduced a law to determine the direction of induced current. This law is known as the Lenz law. What is a Lenz law? Lenz law states that the direction of induced current in such that always oppose the cause responsible for its production. The Faraday discovered that when magnetic flux linked with a coil changes, an electric current induced the circuit. Had the flux changed the cause while the inductions of current in the effect. The Lenz law states that the effect always opposes the cause. To understand Lenz law, let us consider two illustrations in which we find the direction of induced current in the circuit. First illustrations show the figure 4.6. Consider uniform magnetic field with its field lines perpendicular to the plane of the paper and pointing inwards. In the field lines are represented by crosses. Show the figure 4.6a. A rectangle metallic frame ABCD is placed in this magnetic field with its plane perpendicular to the field. The arm AB is movable. So, the disc can slide towards the right or left. If the arm AB slides to our right side, a number of the field lines a number of the field lines reduce it by producing another magnetic field pointing outwards, that is opposite to the existing magnetic field. The magnetic lines of this induced field are represented by red colored circle in the figure 4.6b. From the direction of magnetic field thus produced, the direction of induced current is found to be anti-clockwise by using a right-hand thumb rule. The leftward motion of arm AB decreases magnetic flux. The induced current this time produces a magnetic field in the inverse direction. In the direction of existing magnetic field, figure 4.6c, the flux decreases is opposed by the flow of induced current. From this the found the induced current flows clockwise direction. Second illustrations. Let us move a ball magnet towards the solenoid. With it is a north pole pointing to the solenoid as shown the figure 4.7b. This motion increases the magnetic flux of the coil with the turn. Induced on electric current due to the flow of induced current. The coil becomes a magnetic dipole whose two magnetic poles are on either end of the coil. In this case, the cause producing the induced current is the moment of the magnet. According to Lenz's law, the induced current should flow in such a way that is oppose the moment of the north pole towards the coil. It is possible if the end near the magnet become north pole, figure 4.7b. Then it repels the north pole of the bar magnet and oppose the moment of the magnet. Once pole ends are known, the direction of induced current would be found by using the right hand thumb rules. When the bar magnet is withdrawn, a near end becomes south pole which attracted north pole of the bar magnet, opposing reducing motion of the magnet, the figure 4.7c. Thus, the direction of induced current can be found from Lenz's law. Next one of the topic, conservation of energy. The truth of Lenz's law can be established on the basis of law of conservation of energy. The explanation of as follows. According to Lenz's law, when the magnets move either towards or away from the coil, The induced current produces oppose its motion. As a result, there will be always be the resisting force on the moving magnet. Work has to be done by some external agency to move the magnet against this resisting force. Here, the mechanical energy of moving magnet is converted into the electrical energy, which in turn gets converted into the joule heat in the coil. That is, energy is converted from one form to another. In the induced current help the causes responsible for its productions. Now, when we push the magnet little bit towards the coil, the induced current helps the movement of the magnet towards the coil. In practice, no such machines is possible. Therefore, assumptions that is a induced current help the cause is wrong. Next topic, one of the topic, Fleming right hand rules. When a conductor moves in the magnetic field, the direction of motion of the conductor, the field and the induced current are given by Fleming right hand rule and in as follows. The thumb fingers, index fingers, and middle fingers or right hand are stretched out of a mutually perpendicular direction. If the index fingers point the direction of the magnetic field and the thumb fingers indicated the direction of motion of the conductor, the middle finger will be indicated or direction of the induced current. The Fleming right hand rules is known as